everyone! Welcome to this video on 8.1 Solving Equations Involving Fractions and Decimals. This is going to be a very important video because this is going to be the most complex video that we have done this chapter, in this section here, 8.1. And after we finish this video, then we're going to try some practice problems, and for the next couple of days we're going to do some practice, and then you guys are going to do a quiz over this exact video. So there is going to be a quiz over this, so this is a very important video. Just like always, we will need to take notes as we're watching this video, so go ahead and grab out a piece of paper. At the top of your paper, you can write down the title, 8.1, Solving Equations Involving Fractions and Decimals. Let's get started. Go ahead and write down this first problem here. X plus 1 over 10 equals 3 over 10. So in this problem, we're trying to solve for x. We are going to use the isolating the variable method that we learned in the previous video. In order to isolate the variable here, I'm noticing that the 1/10 is being added to the x. Do you remember what to do to isolate this variable if a number is being added to it? You always have to do the opposite operation. So to isolate this variable, if 1/10 is being added to the x, I have to subtract 1/10 away from the x. When I do that, the 1/10 and the minus 1/10 are going to end up canceling out. And now I have isolated my variable. But when I do the subtracting 1/10 on the left, what do I also have to do on the right? I also have to subtract 1/10 on this side. Because remember, an equation can be set up kind of on a scale like this. You have x plus 1/10 on one side, you have 3/10 on the other side, and you need your scale to be balanced. So if you take something away from this side, you have to take away the same thing on this side in order to keep it equal. How do we take away 3/10 minus 1/10? Remember, to add and subtract with fractions, the denominators have to be the same. And then the numerators, you just add them or subtract them. So since the denominator is already the same here, we can just do 3 minus 1, which gives us 2 over 10. And we can simplify that to 1/5. So in this problem, x is going to equal 1/5. The problems that we do today, a lot of them are going to be similar to this. So we just kind of have to remember how to do some operations with fractions and decimals, and now we have to apply what we learned about fractions and decimals in solving equations like this. Here's the next problem. 3y is equal to 2/3. All right, we're still using the same method of isolating the variable. In that method, we have to look at our variable here, and we have to get rid of anything that is by the variable. We need to get the variable alone. So we need to get rid of the 3. We can't just cross it out. How do we get rid of it? To get rid of the 3, you have to do the opposite operation. What operation is currently happening here in our problem, 3y? It means 3 times y. I have to do the opposite of times, which is divide. So I have to divide by 3. That will get rid of the 3. And then on the left, I will have y. But remember, if you do something to the left, you have to also do the same thing to the right. Oh goodness, how do we do that? We have 2/3 divided by 3. Remember, to divide fractions, you have to keep, change, flip. I'm going to keep the 2/3 the same. I'm going to change the divide to a times, and instead of 3, I could have written this as 3 over 1. I'm going to flip it, so it's going to be 1 over 3. So we did keep, change, flip in order to divide with fractions. Now when I multiply these fractions together, to multiply fractions, you do top times top and bottom times bottom. 2 times 1 equals 2, and 3 times 3 equals 9. So my answer is 2 over 9, 2/9 is my final answer for this problem. All right, now I have done 2 problems as examples for you. I'm going to ask you guys to try 3 problems on your own. These are the 3 problems for you guys to try. Please pause the video, try these 3 problems, and then you can come check your answer. All right, these are the 3 answers for those 3 problems. The first one, it kind of already walks you through how to get that answer. Let me walk you through number 2 and number 3. For number 2, when I try to isolate that variable, I have to do the opposite operation of whatever's happening in the problem. I notice that in this problem, we are adding 1/8 to k, so I have to subtract 1/8 from k, and then I have to subtract 1/8 on this side as well. These will cancel, and I get k equals, then I have to do 7/8 minus 1/8. In order to subtract fractions, the denominator, as long as it's the same, the denominator stays the same. And for the numerator, we do 7 minus 1, which gives us 6. Now we can simplify this by dividing the top and bottom by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. So the final answer is 3/4. For number 3, we have 4p equals 3/4. I notice that multiplication is happening here in my problem, so I have to divide by 4, and I have to divide by 4 over here. So now I have to do 3/4 divided by 4, or 4 over 1. Remember, to divide fractions, we keep change flip. I'm going to keep the 3/4 the same, change divide to a times, and flip the 4 over 1 to make it 1 over 4. Then I'm going to multiply top times top and bottom times bottom, and that gives me my final answer of 3 over 16. All right, guys, that was just our warm-up. We are just getting started. Here's the next type of problem that we're going to solve. In this problem here, we're still going to solve it using the same method of isolating the variable, but notice now our variable is being multiplied to a fraction. That's not actually a problem for us. Since I know that multiplication is still the operation that's happening here, I know that I still need to divide both sides by the number 3/4. So I'm going to divide this side by 3/4, and I'm going to divide this side by 3/4. These ones will cancel here, and I get y equals 9 divided by 3/4. Remember, to divide with a fraction, you keep change flip. So I'm going to keep the 9 the same, but I am going to make it into a fraction, but it's the same number, 9 over 1, so keep that the same. Change the divide to times, and flip the 3/4, so now it's going to be 4/3. Now I can multiply top times top and bottom times bottom. However, I notice that I can cross cancel in this problem. I can cross cancel the 9 and the 3. I can divide them both by 3. So 3 divided by 3 equals 1. 9 divided by 3 equals 3. Now that I've done that step of cross canceling, I can continue with my problem, and I can multiply top times top to get 12 and bottom times bottom to get 1. So my final answer is positive 12. Did you know there's actually a shortcut to solving this problem? I'm going to do the exact same problem for you right now, but I'm going to do it using a shortcut method. So the same problem that we just did was 3/4 y equals 9. Here's the shortcut. The shortcut method is, if a variable is being multiplied to a fraction, instead of going through the whole keep change flip and all of that, you can actually multiply both sides of the fraction by the reciprocal of the fraction. The reciprocal means that you would flip the numerator and the denominator and make those go in the opposite spots. So the 3 is going to go here, and the 4 is going to go here. So I can multiply both sides of this by the reciprocal of 3/4. Why does that work? Well, let's take a look at that here. When I multiply 3/4 times 4 over 3, what's going to end up happening there? The number on the top, I'm going to have 4 times 3, which is 12. And the number on the bottom, I have 3 times 4, which is 12. What does 12 over 12 equal? It equals 1. So by multiplying both sides by the reciprocal, I have successfully isolated my variable by canceling out this number, because if this just equals 1, 1 times y, it's just going to equal y. So I've canceled out that number, I've isolated the variable by multiplying both sides by the reciprocal. So in this case, you can skip a lot of the steps and you can jump straight to this step right here, where we did 9 times 4/3. That's what we're doing here, 9 times 4/3. So you get to skip all of these steps right here if you want to. You can multiply both sides by the reciprocal instead of dividing by the fraction. Either way, you'll get the same answer. We're still going to multiply 9 over 1 times 4 over 3. We're still going to cross cancel here. And when we continue to multiply top times top and bottom times bottom, we're going to end up with the same answer. I have a few practice problems for you to try, and you can try either method that you would like to. Here's the first one. Go ahead and pause the video, see if you can solve this problem, and find out what x is equal to. All right, in order to solve for x here, I'm going to use our shortcut method of multiplying by the reciprocal on both sides. So I'm going to multiply both sides by 5 over 2. 5 over 2. On this side, my 5 over 2 times 2 over 5, those will end up canceling out. That's just going to equal the whole number 1. So I'm going to be left with x, which is exactly what I want when I'm trying to isolate my variable. And then over here on my other side, I'm going to multiply these numbers together. 12 over 1 times 5 over 2. When I multiply these numbers together, I'm going to cross cancel here by dividing both of those numbers by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Now I'm going to multiply the numerators together. 6 times 5 is 30. And the denominators, 1 times 1 is 1. So this can simplify to 30. So the final answer for this problem is 30. Here's one more for you to do. Go ahead and pause the video, see if you can do this problem here. All right, to do this problem, I'm going to multiply both sides by the reciprocal of 3/7, which is 7/3. When I multiply on the left by the reciprocal, these end up canceling, and I get y equals. And then when I multiply the 12 by 7/3, I have 12 over 1 times 7 over 3. And I'm going to cross cancel by dividing both of those numbers by 3. And then I can multiply my numerators together, and I can multiply my denominators together, and I get the final answer of 28. All right, so we did fractions. Now we have decimals. Don't worry, the decimal problems are a lot easier. This is the first decimal problem for us to take a look at. We have 3.4 equals x plus 1.2. When I solve this problem using the isolating the variable method, I notice that the operation I have in this problem is addition. That means that I need to subtract 1.2 on both sides of my equal sign. So I'm going to subtract 1.2 and subtract 1.2. When I subtract 1.2 on the right, these numbers cancel, and I'm left with x, which is exactly what I want. I want to isolate my variable x, get it by itself. And on the left, I subtract 3.4 minus 1.2. Remember, when you're adding and subtracting with decimals, you need to line up the decimal points. You need to make sure that the decimal points are right on top of each other, and then you just add and subtract like normal. 4 minus 2 is 2, and 3 minus 1 is 2, so my final answer should be 2.2. Go ahead and try this next problem on your own. You can pause the video and then you'll be able to see the answer in just a minute. All right, in this problem here, I noticed that my operation that we're using is subtraction, so I need to do the opposite thing. So I'm going to add 6.7 to both sides. When I add 6.7 to both sides, this 6.7 is going to cancel, and I get W equals, and then I add these like normal. I make sure that my decimal point is lined up here, and I add the 2 plus the 7, which equals 9, and 3 plus 6, which also equals 9. So my final answer should be 9.9. All right, let's try this problem here together. 3x is equal to 12.9. Which operation is happening in my problem? Multiplication is happening. 3x means that it's multiplication. What's the opposite of multiplication? Division. So that means that we need to divide both sides by 3. When we divide on the left by 3, 3 divided by 3, that cancels out, that becomes a 1, so we have 1x, or we can just write x. And then on the right we have to do 12.9 divided by 3. Now you have a couple of choices for how you want to do this. You can use a calculator, and yes, you will be allowed to use a calculator on the test. So you can just type this into your calculator, 12.9 divided by 3. But if you want to get more practice with dividing with decimals, this is how you would set the problem up. 12.9 divided by 3. 3 goes into 12 4 times. 4 times 3 is 12. I would subtract and get 0. I bring down my 9. 3 goes into 9 3 times. And I make sure that my decimal point stays right here. So my final answer is going to be 4.3. Again, you will be able to use a calculator, so if you just type that into your calculator, that is totally fine. This will be our final answer for the problem. I have just one last problem for you to do today, and that is right here. Go ahead and pause the video, try this problem on your own. Yes, you can use a calculator, and then you can watch the video to check your answer. All right, I'm noticing that in this problem, the 5.4 is being multiplied to the y. The opposite of multiplication is division. So I am going to divide both sides by 5.4. In my calculator, I can type in 6.48 divided by 5.4. And you can get the final answer that way. Or if you want to set it up by using long division, this is how you would do that. 6.48 divided by 5.4. I'm going to move both decimals one time so that I get to divide by a whole number. So now my problem is 54 on the outside and then 64.8 on the inside. 54 goes into 64 one time. 1 times 54 is 54. I subtract and get 10. I bring down my 8. 54 goes into 108 two times. 2 times 54 is 108, so I subtract and get 0. And I make sure that my decimal point, which I had moved to right here, ends up in the same spot. So my final answer should be 1.2. Y equals 1.2. If you type this into your calculator, you should also get 1.2. Alright guys, that is it for this video. Now you know everything about one-step equations. You can add, subtract, multiply, and divide with fractions and with decimals. Great job. Go ahead and take a picture of your notes and you can submit that onto Canvas for this video.